Okay, in this video, we're going to solve dot product quiz. So the first question was related to finding out the projection of a vector, which was given by 2i cap plus 3j cap plus 6k cap um, on the vector b, which is 2i cap plus j cap plus 2k cap. So essentially, what we're saying is if this is an a vector, we need to find a perpendicular vector, a projection of a vector perpendicular to b vector, which is basically essentially is what we are saying, a y vector. Now we know that projection of a vector along b vector is which I'm calling as x vector, is given by a cos theta in the direction of b vector. So basically a cos theta dot b cap. With dot product, we know that a cos beta is nothing but a dot b by b cap by magnitude of b, and we can write b hat as b vector by magnitude of b. So we have a dot b by magnitude of b square to b hat. Now so y vector by law of parallelogram is a vector minus x vector. So which is basically replacing x vector here, we get an equation. And now let's substitute a vector, which is 2i cap plus 3j cap plus 6k cap, and b vector, which is 2i cap plus j cap plus 2k cap. So replace these two and solve this equation, and you will get this as an answer. Cool. So let's move to second question of our quiz. Okay, so the second quiz says that angle which is enclosed in a semicircle is 90 degrees, and we need to prove that. Okay, so let there be a midpoint O, and let's say that's an origin, and there are 3 points A, B, and C. But since this is a semicircle, AO, OB, and OC will all have a same magnitude, and let's say that it is R. Also, given this is a straight line, I say AO vector, if OA vector is equals to A and OC vector equals to minus A. So if I say this vector is A, then this vector has to be minus A vector if from origin O. And the magnitude of A vector is equals to R. Now let's see this triangle AOB. You can say AB vector is nothing but AO vector plus OB vector. AO vector is minus A vector plus R vector. Similarly, in this triangle OBC, BC vector is equals to BO vector plus OC vector, law of triangles, which is minus R vector minus A vector, which is minus of A vector plus R vector. Now if I do a dot product of these two vectors, we would see it is A square minus B square, right? A square minus B square. Now we know magnitude of A is same as magnitude of R, so this value comes out to be 0. So the angle enclosed between AB and BC, which is this angle theta, is such that the cos theta should be 0, and hence that can only happen when theta is equals to 90 degrees, which proves that angle enclosed in a semicircle is 90 degrees. Great. Let's go to third question in the quiz. Okay, so the third question says prove this identity, which is cos alpha minus cos beta is equal to cos alpha cos beta plus sin alpha sin beta. So let's consider a quadrant X and Y, and there is a vector A which has an angle alpha with x-axis, and then there is a vector B which has an angle beta with x-axis. So I can represent A as its component across x and component across y. So we can say A vector is magnitude of A vector cos alpha, which is the component along x, I cap, plus A vector sin alpha, which is the component along y, so A sin alpha j cap. Similarly, I can say B vector has its component along x-axis, which is magnitude of B cos beta I hat, plus the component along along x-axis or along y-axis, which is magnitude times the sine beta and the unit vector along y. So let's do a product A dot B. So if I do a dot product of these two vectors, it will be multiplication of these two, which is AB cos alpha cos beta, plus the component along y-axis, which is AB sin alpha sin beta. Remember how to solve A dot B. But again, the angle between A and B is this, which is alpha minus beta. So we can say it's magnitude of A into magnitude of B into cos of angle between A and B. Taking out magnitude of A and B common, we have cos alpha cos beta plus sin alpha sin beta. So we can cancel this with this, and we can cancel this with this. So we get cos alpha minus cos beta equals to cos alpha cos beta plus sin alpha sin beta, which is basically the property we wanted to prove, right? So you can use dot product to prove cosine formula or trigonometric identities. Great. Let's move to next question in the quiz. Okay, let's go solve fourth question. So in fourth question, we have been given a point A, which has a vector I hat plus 0 j cap plus k cap, and then we have a position vector of B, and then we have a position vector of C, and we wanted to find the length AB. So how do we solve this problem? So let's define a vector X, which is, let's define this vector X hat, which is a BA vector, which is nothing but position vector of A minus position vector of B. So that's 1 minus 2, which is minus 1, 0 minus 3, which is minus 3, and 1 minus 4, which is minus 3. Similarly, let's define a vector Y, which is BC vector. So we say BC vector is position vector of C minus position vector of B, which is minus 1, minus 2, which is minus 3I hat, minus 2J hat, and minus 6K hat. Now we wanted to find this vector. So we can say that PB vector plus BA vector is equals to AP vector. So PA vector, which is this vector, is this plus this. Now we already know BA, which is X vector, but we don't know PB. So we need to find what PB would be. PB is nothing but a projection of X vector on vector BC, right? So we already know it. So it is basically X cos theta, if this angle was theta, which when given by a dot product is given by X vector dot Y vector divided by mod of Y vector whole square dot Y. So we can say that it is X cos theta Y hat. Right? That's what PV vector would look like. And X cos theta can be written as X dot Y by mod of y, and y can be written as y hat by mod of y. Right? It will give us this formula. Right? So now we know x vector, we know y vector. It's basically now about solving this equation. So we'll get PA vector, substitute the values and solve for it and find the mod, and you will get this answer. Okay. So again, dot product can help you find out the length of a line which is perpendicular to a vector if we know position vectors of these 3 points. Great, so this is another application of dot product. Okay, so the last question is we need to prove this identity. A1 b1 plus a2 b2 plus a3 b3 whole square is less than equals to a1 square plus a2 square plus a3 square multiplied by b1 square plus b2 square plus b3 square. Now if you look very closely to this equation, this looks like a dot product between a and b vector. If a is defined as a1 I hat, a2 j hat plus a3 k hat, and b is defined as b1 I hat plus b2 j hat plus b3 k. So this is basically our definition of dot product. This is basically square of the mod of a vector, and this is square of mod of b vector. Now we know that dot product is a dot b is equals to a b cos theta. So if we do whole square, we get this equation. So a dot b whole square, if I bring both of these down, so mod of a whole square mod of b whole square is equals to cos square theta, and we know that cos square theta lies between 0 and 1, okay? Because cos theta lies between 1 and minus 1, so square would lie between 0 and 1, so this value would always be less than equals to 1. So this whole value is less than equals to 1, so we can say that a dot b whole square is less than equals to mod a square mod b square, which is basically this formula. Right? So we have seen 5 different applications of dot product. Now we will move to new concepts, which is a vector product.